Hey guys, so let's discuss new interview loop round, which is round 3 for the Microsoft, and which is called coding round 2. Okay, so here in this coding round 2, we will be discussing problem top k frequent elements. Okay, so we will be discussing solution based on 3 roles: software engineer, senior software engineer, and architect. So now what is top k frequent element problem is? Okay, so here you would be given the integer array number, let's say. Okay, and you have an integer k, so you need to return the k most frequent element. So for example, if the array is something like this: 1 comma 1 comma 1 comma 2 comma 2 comma 3, it means that 1 is coming thrice, 2 is coming twice, and 3 is coming once, right? So top k frequent element, where k is equal to 2, let's say. So top 2 elements, which is coming more, right? So frequency is more, so 1 and 2, because it is 3 and 2, right? So this one will be your answer. So this is what you need to find. So this is another very common Microsoft coding interview question. Okay, you might see this question in your interview as well. So unlike Amazon, Microsoft expects start with the simple solution, improve it step by step. Okay, then analyze time and space complexity, discuss production scale scenario like streaming, distributed system, and parallel processing. Okay, so right now I have given you one array, okay, whose length is fixed. So for example, here 3 and 3 6, length is 6. But what if it is a stream of input? A stream of input means you are getting the elements 1 1 1 2 2. You don't know the n, which is the size of the array. What is the size of the array? Continuously you are getting the element in that case. So in the scenario of streaming, okay, streaming of the integer number, what you will do, or what you will do for the distributed system or parallel processing. Okay, how you will use parallel processing to process it faster. Now again, expectation differ by level here. So software engineer 2 to 5 years of experience will just give the correct algorithm with complex analysis. Okay, complexity analysis, time complexity, space complexity. So senior software engineer 6 to 12 years of experience, optimize algorithm, streaming, concurrency, and scalability he will be talking about. Principal engineer or architect 12 years of experience, so 12 plus years of experience, will be talking about distributed top k, then approximate algorithms, and fault tolerance and benchmarking. What is approximate algorithm? We will see that. Okay, now so software engineer will answer for this. The expected answer would be from his side is, I will first count the frequency of each number using HashMap. Okay, and then I will use bucket sort to achieve better than order and log n time. So what he's saying, first he will use the HashMap. Okay, HashMap, and he will count that 1 is coming thrice, 2 is coming twice, and then 3 is coming once. Okay, and then now second thing, what you will do, you will sort it, okay, based on your frequency. So like it will come something like this: 1 comma 2 comma 3, because the frequency is 3 comma 2 comma 1. So on the basis of frequency you have sorted, and then you will return first 2 elements. So this is first k element. So what will be the time complexity? See, for HashMap it is order n, because you have to traverse once, okay, the entire array. Now for sorting, what will be the time complexity? N log n. So total how much? So order n, okay, plus order n log n, which is equivalent to order n log n only. Okay, so now he is saying that can you optimize it further? So yes, we can optimize it further. You can use bucket sort, so it will take order n only. Okay, now we will see what is bucket sort and how you will apply bucket sort in this method. Okay, in this problem we will see that. Okay, so let me clear this solution. Okay, yep. So now see the solution. First he is also talking the same. Okay, count frequency using HashMap, sort the frequency, and return top k element. So it will take order n log n time complexity, n log n for sorting, and order n for HashMap. So whatever is maximum, we take that. Now so here the build HashMap will take the space complexity order n, and sorting will take n log n. So total will be n log n, where m is the number of unique element. Okay, so now better solution is bucket sort. So first discuss what is bucket sort. So see, bucket sort is a sorting algorithm that works putting number into different groups, okay, or buckets. Then sorting each group separately. So how? See, let's say you have given this number 42 okay, 32, 33, 52, 37, 47, 51. So you will create groups or a buckets. Okay, so let's say your bucket is something like this. The range is 30 to 39, all the number, okay, between 30 to 39 will come here. Then range would be 40 to 49, then 50 to 59. Okay, so now you have put it all the number in a group, and now each group you will sort separately, right? So sort each group. So this one will be bucket 1, bucket 2, bucket 3, and then at the end you will join all those group. So this one will be your answer would be sorted here. Okay, so here time complexity, for the best case or for the average case, it would be order n, okay, when data is uniformly distributed. But let's say everything falling into one bucket only, okay, then the time complexity will be order n square. Okay, this is normal sorting algorithm. So worst is order n square if all elements are end up in one bucket. Since frequency can never exceed n, okay, so you need to use bucket. Now frequency is something like this. Let's say 1 is coming thrice, 2 is coming twice, 3 is coming once. So you will create a bucket like 0, 1, 2 and 3, and you will put this frequency there. So for example, 1 is coming thrice, right? So you will put 1 in frequency 3, then this 3 in frequency 1, 2 in 2, and then you will traverse this, okay, this traverse buckets for the highest frequency. That's it. So it will take order n complexity for the best and average case, okay, not for the worst case. Now let's see the Java program for bucket sort. Okay, so let's say you have a solution class in which you have a method, say top k frequent element, which will return you integer array, okay, sorted list, sorted array, and then it is taking two parameters, which is number array, which is your actual array, and then k, top k elements, right? So initially first you will create one map, let's say frequency map of type integer comma integer, okay, and then you will traverse that array, and one by one you will count the frequency of each element and put it into the hash map. Okay, so either 1 or either if it is default nothing is there, then 0, otherwise the existing frequency plus 1 you will add. Now after that you will create one bucket list, okay, array, bucket list array, which is all holding list of integer. Now you will again traverse this frequency map. Okay, you will traverse this frequency map, you will get the key set, okay, all the key set you will get, and one by one you will traverse with that key set. Then you will check that for that particular key, okay, what is the value, and then you will check if bucket f is equal to null, means you have not put it that value there into the bucket. So you just create the new array list and you will add this key into the that bucket f. Okay, so normal list of list we are using here, and at the end you will traverse again that bucket array, list of integer array, okay, for to fetch the result from that. So you will create one result array, okay, and then you will just traverse that bucket, okay, from length -1, because the highest frequency is at the end, and you will check if it is not null, then you will just traverse that, okay, and you will add that number into the result. And if the index is equal to k, you don't need to traverse complete bucket array, okay, just k, you need 2 elements. So from last you just take the 2 elements, right, and then break. So that's it, very simple. Now here complexity, so frequency map space complexity would be order n, okay, bucket creation order n, bucket traversal order n, so total will be order n, because order n plus order n plus order n is equal to 3 order n, which will again equivalent to order n, okay, constant time, because this is the constant, right? So this is the constant time only, so that's why order n is space complexity. Okay, now senior software engineer, what he will be answering for this is, for interview purpose bucket sort is optimal, okay. In production the algorithm depends on the data size, whether input is streaming and available memory. See here one thing, if the input is streaming, okay, continuously you are getting a stream of integers, then you don't know the size of the array, right, because this is the continuous streaming is happening there. You don't know the value of n, then on what basis you will create the group, right, for the bucket sort. So you cannot use bucket sort there. you will use a heap sort there. Okay, so you will create a heap of size k, and you will add the element there. Okay, if it is greater, if the frequency is greater, then you will add that element there. If it is not, then and if the size is already full, then you just heapify it. Okay, add the new element, heapify it, and if not, then no need to add there. Okay, so if the input is streaming, bucket sort is not suitable because you don't know n, okay, total elements in advance. The maximum frequency is unknown and you cannot pre-allocate the bucket array. This is what I just told you. So production decision matrix will be something like this. A small data set, so you just go with the bucket sort. Okay, if it is a large unique value, then go with the minimum heap, what I just told you. If it is a streaming, again minimum heap plus HashMap. Okay, if it is distributed, then map, reduce, or spark. If it is approximate, then use count, minimum, sketch. So we will see what is approximate search. You will use the best approach is count, minimum, sketch there it is called. Okay, the architecture will be something like this. Okay, you will get the input stream, let's say, and a stream of input is coming. So event, request, transaction, logs. Okay, you will add all the logs there, and then you will have a frequency counter. Okay, in HashMap it will count that item is coming how many times, and after that you will use the top k engine algorithm. Okay, keeps only the top k most frequent items. So this is what I told you in heap. Okay, you will use the minimum heap of size k. Okay, so minimum heap of size k. If item is new and heap is not full, then add it. And if item frequency is greater than minimum frequency in heap, so replace and heapify. Okay, and then time complexity order log k per item it will take, right? So the result, so now you have created top k engine, and then the result will be top k most frequent item would be your answer. So this one is normal architecture. Now here the enhancement, what you can do is parallel counting. Okay, what is parallel counting? Split the input across multiple threads or servers, so frequencies are counted faster. Okay, instead of one complete process, you just divide that into a chunk, and each chunk will be processed separately, and then later you aggregate it. Okay, now the next is streaming update. So continuously update frequencies as new data arrives instead or waiting for all the data first. Okay, then metrics. So track statistic like processing time, throughput, and memory usage, top k update frequency to monitor performance. Okay, now memory optimization, so reduce memory usage by storing only necessary data, or using efficient data structure and approximate algorithm for very large data set. So here also he is talking about approximate algorithm. So we'll see what is top k approximate algorithm. Now principal engineer or architect, what he will be saying is the expected answer would be an enterprise scale top k become a distributed analytics problem, right? So I would partition the data and compute local top k value and then merge them effectively while considering fault tolerance and approximate algorithm for very large data set. Again here he is talking about approximate algorithm. So he will divide the chunks. Okay, let's say the stream of input is very large, so he will divide that into chunks, and then he will find the top k from each chunks, and then later he will aggregate it. So enterprise architecture will be something like this. First you will have a event stream. Okay, continuous events from user or system, let's say, and then it will go to Kafka, and there you will have a multiple partition. Okay, each partition will process it separately. The worker node would be there. Okay, consume events and calculate local counts. So worker node will help you to find the top k local elements, okay, for each partition. And then once you find the local top k elements, okay, each worker maintains its local top k. So you will have different top k elements, okay, local top k elements, and then aggregate aggregation service, merge all local top k and recalculate global frequencies. Okay, and then later you will have one global top k value. So guiding principles would be here horizontal scalability, right? Because you have used multiple, here you just add new partition, okay, new partition, or new worker. Let's say if the input of a stream is very large, then in that case, so horizontal scalability is there. Then fault tolerance, okay, streaming support, low latency, and cost optimization. Now let's talk about here follow-up questions. So we will be talking about 5 follow-up questions here. Okay, can you solve it better than order and log n time? Yes, we have seen that using bucket sort you will be using, right? So software engineer will say yes, bucket sort achieve order n because the maximum frequency is bounded by the input size. Okay, now what is the problem with that? If it is a stream, then in that case you cannot go with bucket sort, you have to go with the minimum heap. Okay, so senior software engineer will say bucket sort is optimal when frequencies are bounded. If the number of unique element is much smaller than n, a minimum heap with size k may also perform well. Okay, so that is also you can use if the number of element is less than n. Now principal or architect will say that optimal algorithm depends on the workload characteristic. Okay, how your workload is. For bounded frequencies, bucket sort is ideal. For streaming or distributed system, heap based or approximate method are more practical. Okay, now what if data doesn't fit in memory? So in that case, split the data into chunks. Okay, that is what senior software engineer will say. Senior software engineer will say about the approaches. Okay, what you can use external sorting. Okay, you just sort it outside and then just get the data, or chunk processing, or merge partial results. Okay, so principal architect will say that let's say you have a huge data set. Okay, massive amount of raw data you have, and billions of records you have, let's say. So you will partition those into the different files. Okay, that data, part 1, part 2, part 3, part 4, and then workers will work on each part. Okay, and then we'll find the local frequency, something like this, and then global merge. Okay, you will just merge global frequency there, aggregate all local frequencies to get the global frequency. That is what we are telling from longer time. Okay, use distributed framework like Spark or Hadoop. So this one we will use in the case of distributed framework, and architect will answer around this. Okay, now follow up question 3 is streaming input. So software engineer will say that continuously update the frequency map. Let's say you are getting streaming inputs. Okay, you don't know the size of the array, then in that case continuously how you are getting the streams. Okay, just update the frequency of in a hash map, that 1 is coming thrice. Okay, 1 again came, oh, change it to 4, something like that. Okay, and then senior software engineer will say that maintain hash map for frequency and minimum heap for the size k. And principal architect will say that you use Kafka plus event processing. Okay, so in this way your system will be more flexible. Okay, so producer or user, or let's say IoT or apps will produce the input of a stream. Okay, and then it will go to Kafka topic. From there streaming processing will happen there. Okay, using Kafka streams. Kafka streams is a Java you can say Java lightweight Java program. Okay, which will help us to work with this Kafka. We'll see that. Okay, and then frequency counter will be here, and top k result. Okay, the same thing. So now Kafka streams. What is Kafka streams? We have seen this Kafka stream here, right? So what is that? So a lightweight Java library that reads event directly from Kafka. Okay, best to building real-time processing into Java microservices. Example, continuously calculate the top k searched products. Okay, now follow-up question 4 is related to distributed top k. So from longer time I was telling you that we will discuss what is top k, approximate top k. Okay, algorithm. So we'll see that. Okay, distributed top k. So software engineer will say that each server compute its own top k. Senior software engineer will say merge local top k values into global top k value. And principal architect will say that node A, let's say he has the top 100. Okay, B has top 100, C has top 100. Then aggregated service will find the global top k value. Okay, among all this. So advantages: so parallel execution, lower network traffic, and horizontal scalability. Okay, now see, approximate top k is something like let's say we are working on the searching algorithm. Okay, user has searched, let's say, Java 23 lakh times. Okay, Python 56 lakh time. Okay, and let's say C++ 10 lakh times. Okay, so instead of adding all the values row wise, like 23 lakh rows and then 56 lakh rows and all, we will just add that. Okay, Java approximately Java has searched 23 lakhs time. Okay, it is approximate top k. Okay, not exact, but yeah, approximate, and on the basis of that you will calculate approximate result. Okay, so that is the approximate k top k algorithm. Okay, now real-time updates, if you talk about here, so software engineer will say that update frequency whenever new data arrives. Okay, this is already we have discussed. Senior software engineers say maintain frequency map, heap, and incremental updates. And principal architect will say that support event driven update, sliding window, incremental recomputation, and low latency queries. So that's it. Thank you.